Hello, everyone. Welcome to the webinar. We'll be getting started momentarily, so come on in and make yourselves comfortable, and we'll be underway soon. Hello, everyone. Welcome to webinar number 2. We'll be getting started in a few minutes, so hopefully you all can hear me okay. Like I said, we'll be starting in a couple of minutes, so get comfortable and stay tuned. Hello, everyone. I see people are still kind of filing in the room a little bit, so I'm just going to give it one more minute before we start. So make yourself comfortable. We'll be starting in 1 minute. Okay, everyone, let's go ahead and get things rolling. Greetings. My name is Chris Murray, and welcome to the Unreal Engine for Architectural Design Visualization, webinar number 2. Joining me today is Fabrice Borelli, all the way from London, England. He's been a long-time professional 3D visualizer and has recently, within the last year or so, picked up the Unreal Engine, is really just doing some amazing work. So we're really lucky to have him here today. And he's going to be showing us lots of different stuff in the Unreal Engine. So let's go ahead and just kind of jump right in. I'll get my stuff out of the way and we can get right to Fabrice. So for those of you that may be relatively new to the Unreal Engine and not really know what Epic is all about, Epic Games has been around for 18 years, and we've been really one of the premium award-winning real-time engines out there. About 18 months ago, we really realized that a lot of people were using our game engine for things that are not related to games at all. And so we formed a team called the Enterprise Team. And the Enterprise Team at Epic is focused specifically on anything related to your business or work that is non-games related. So aerospace, design visualization, automotive, oil and gas, you name it. If people are using our engine for non-games, the Enterprise Team is here to focus on your issues and challenges. The engine is everywhere. There's over 3 million users worldwide of the engine. And as always, it will remain free and complete access to the full tool set and source code completely for free. So we want to make sure that people are doing great work in the engine, and that's why we do webinars like these. So here we are in webinar number 2. Previously in webinar number 1, we did an introduction to the capabilities of UE4 for architectural visualization. Now, it's not a requirement to have seen that webinar. We're not going to be covering things in here that are dependent on what you may have seen in the first webinar, so don't worry about that. Today's webinar is really about next steps. Once you've seen what was possible in the engine in the first webinar, now we're actually getting into the engine. So it's going to be a lot longer, a lot more technical, a lot deeper into some of the features. You can expect to go about an hour and 15 minutes today. We're jam-packed with a ton of information. So then coming soon, we actually have 3 more webinars teed up. We have webinar 3, 4, and 5, lighting and post-production, materials, and intro to Substance Designer for architecture. Our friends from Algorithmic are probably going to be joining us there. And finally, webinar number 5, VR production. So what are we going to cover today? Like I said, we have a lot to cover, so I'm going quickly through this stuff so I can get out of the way and let Fabrice take over. We are going to discuss the import process of 3D models. We're going to be working with UVs and light maps and kind of talk about that a little bit. We're going to be looking at lighting and materials pipelines. We're going to be discussing post effects, post-process effects, interaction, things like that. So at the end of the webinar, though, I want you to stay tuned for a technology preview. I'm excited to be able to show you some new things that we're working on at Epic. It's about a 5-minute presentation of some things that are coming down the pipe, but that directly relate to what it is we're talking about today. So I think you're going to want to stick around and see that. A couple of other pieces of classroom business. We have a webinar chat room on the side, which I think everybody has found. That's great. I'd like to ask a favor, though. When you post a question, if you look at the dialog box or the field where you actually write your message, you'll notice to the left of that, there's a little drop-down menu with a thought balloon. And if you click that button, you get the option to actually designate your comment as a question. If you do that, those get piped off into a different list. We're going to be doing Q&A after the webinar is over. So if you can ask your question using the question designation icon, that will make it a lot easier for us to actually find your question later after the fact. So we'll be answering some as we go, but for the most part, if you could do that, that would be really great. The other thing we're going to be doing are some classroom polls. And so I'm going to start off by doing a poll right now, just so we can kind of get this out of the way. And you'll see it up here in a second. I'm going to go ahead and start this poll. So here's our first poll. And I'm going to be doing these throughout the webinar. So if you can take a look at that, and we can get kind of gauge and see who's in the room. All right, cool. So for the most part, we have a lot of people here from the first webinar. That's great. That's great. We've done this webinar today for a couple of different time zones, and it's always interesting to see who was here for the first one and how many new folks we have. So looks like we have some nice return visitors and also a good portion of new people. So that's great. Really looking forward to sharing what we know on that. And then there is one more question I do want to throw out there so that Fabrice and I can kind of gauge the room a little bit. And that is your experience with the Unreal Engine. So there I've posted a new poll. Okay, good. I'll let this settle in for one more second. All right, great. So again, we'll be doing Q&A at the end. So if you could just designate your questions as Q&A, that would be really helpful for us. I'm going to go ahead and turn things over to Fabrice. So I'm going to go ahead and stop sharing my screen, and we'll let Fabrice take it away.
Great. Thanks, Chris. I'll just say a little hello, say I'm live here for you, and then I'm just going to disappear again and show my screen. It's Chris as well. Okay, so screen. Welcome to this webinar number 2 for ArcViz in Unreal. So I'm going to I've stepped forward a bit too soon here. In this webinar, we are going to talk about workflow. So I'm just going to describe that a little bit. But the idea here is that we give you all the steps from A to Z, all the steps you need to produce work a little bit like this. Obviously, we're not going to go into complete depth in that. I'll just explain a little bit what when we're going to do that and what, but Chris has mentioned it just in the introduction. We'll have other webinars dealing with that. So what we are going to do, just as starters, is to try and compare these two workflows, the one that I call the V-Ray workflow, which we should mostly be quite familiar with. By V-Ray, really, I mean offline. I assume that most of us will be using V-Ray, since everybody is. But if you're using Corona, Mental Ray, or any other offline renderer, that's absolutely fine. It just applies. And on the second workflow is the Unreal workflow. So this is new to us, it's real time, and there's lots of new things that we'll need to get used to. So just quickly going over again, this should all be familiar to us, but the V-Ray ArcViz workflow will start with our 3D model, quite classic. We'll have something either coming from CAD or we'll have 2D information that we'll model into 3ds Max, and then we'll apply some materials, textures, and then we'll use Photoshop. So that's kind of part of in the workflow. And then we'll start adding our lights. So that's where V-Ray really would come in, and we'll have the the V-Ray dome light, for example, the environment color, the V-Ray sun, and then the GI and all our lights, yes, and so on. Then once all that is all nicely put together, we'll render it out using our passes or ZDepth or any other masks that we'll then use into post-production, whether it's Photoshop or After Effects if we're doing animations and so on. So we'll create then our effects, our post in that software. Now, going on to the ArcViz workflow, just a little word about this final pixel. This is Epic's dedication to this idea of final pixel, where Unreal Engine is actually delivering the pixel on screen, the pixel we see. So it means that it will encompass all of the workflow under one single piece of software, which is absolutely brilliant for us. Much simpler, and since it works very well, great. Another thing about this little diagram here is that although we're going over the workflow, this is heavily front-loaded into this first quadrant here, where we'll be mostly talking about how we get our data into Unreal, different ways we can do that, different ways the do's and don'ts and tricks here and there. Then we'll go into the lighting, which is obviously also handled by Unreal, but with a few new terms here. We've got our light maps, UVs, so that's in the modeling part, but here in the lighting, we've got light maps and light mass. So these are new terms and new techniques. And then we'll go on to the just brush over the material, looking at how the material editor is made of nodes and seeing how maybe some other piece of software are going to come into this workflow, like Substance, to help us with these new materials. Then we'll have a quick look at the post-process volume, what can be done with that. And again, at the end, we'll just talk very briefly about interaction and output, because, so as Chris said, we're going to have other webinars that will go in depth about lighting, and another with materials, looking at Unreal materials and Substance, and then another one looking really more deeply at VR. And so we'll touch on all these subjects more in depth there. So here today, really, the 3D model, we're going to talk a lot about that. So 3D modeling for real time. So you'll see I've kept my little timeline here to so that we know where we are. So 3D modeling for real time, we need to consider a few things. We need to consider where our data is going to come from. And here we have two options. So that the data is modeled or generated in CAD, whether it's 2D or 3D most of the time. And so we need to understand that the CAD software like Revit, SketchUp, Rhino, and so on are generally geared towards creating information that is issued for construction, for creating real life things. So the priorities of the software is to attach a lot of data, especially now with BIM. There will be enormous data sets potentially, with a huge number of objects, and not necessarily catered for the workflow of a video game software, which is what Unreal effectively is, although now we're transforming it into an architectural visualization software. But the fact is that there are the softwares like 3D Studio Max, Maya, Cinema 4D, and Blender, for example, are softwares which are more geared towards generating visual imagery, and they work differently. So we will need to make that jump. And the second option we have here is to use a software like 3D Studio Max to manage our data and to send it over to Unreal. So let's look at this option number one. I just took a very simple example, found this lovely model on a 3D warehouse for SketchUp. So I just loaded that into SketchUp, and you see that I've exported it as an FBX and imported it straight into Unreal, and this was the result. It's pretty clean. It works. It looks all right. Everything's there. When we go inside, all the furniture is there. Nothing's upside down or miles away, and so it works. It's pretty cool. But, because there's a but, is that it's a bit of a mess. The objects were imported with the name of the FBX and were appended a number at the end. So that's really not going to help us very much at all when we want to manage the project down the line. And we have a very high number of objects here, 800 objects for this small little house. It could be a lot simpler for us. So the other problems we have is that we get the wrong normals. So the faces of the 3D model are facing the wrong way, and we can see straight through it. And then here we've got this very horrible looking invalid light map setting. So that's not very jolly, but after a little bit of cleanup, really didn't take long, maybe half an hour to an hour, I've managed to fix everything, put the light, build the lighting, and it looks pretty good. You know, it's like I said, it works. Everything's there. In fact, I've got it loaded here, so I just show you around. You know, everything's working well. There's a few problems here that we will need to sort out. So that's my point. But in general, it's very usable. You know, it's for client presentation or for a checkup and being able to see where we're at. So I'm just going to close this file now, and before continue, load my next one so you don't have to watch it load. So here we go, carry on. So conclusion of this method number one, it's quick and it's extremely valuable in the design process where we effectively are very much used to work with this white card model. It's very useful for pre-visualization, concept design, massing studies, you know, a light study having views. I'm thinking particularly in a large scale urban project or a master plan, things like that. The data comes in very clean and it's very usable as I've shown in the example. So of course, the problems I've highlighted are going to probably become much bigger on larger models, and that's why we have the option number two. So let's look at that. So the data doesn't always come in 3D. It's not always as clean as I've just shown you. So we also have the option to obviously work with 2D DWGs, or sometimes they just come as PDFs, and we can import any type of data into 3D Studio Max. Then we'll use that to manage the project and then export it to Unreal. So that's via FBX. So what's the advantage of working this way? Well, it's the professional workflow today. I haven't actually met any person who works either in a visualization agency or as freelance or in a design agency, an architecture agency that doesn't do that. So it's the accepted workflow today. So the enables us to obviously have this clean geometry. If something's wrong, we can deal with it. We can remodel it. Once it's organized, and I'm going to talk about that in a minute, we can manage design changes. So this recursive workflow of going back and forth is going to be much easier when we have control over all our objects and everything's nice and tidy. We can obviously start optimization. So if you attended the first webinar, we talked a lot about real time, and this is a requirement of real-time technology that everything is optimized. If we just throw a huge number of objects and polygon, the engine is going to, or the video card is just going to start crawling, and we will lose our real-time experience. And then finally, slight problem, 3ds Max is pretty expensive just to manage a model. So I've just put Blender as possibly an option. I've heard people in the industry are using Blender to create visualization. So why not? I'm going to have a look at it in the future. So once we have our data in our software, in this case 3ds Studio Max, then we will have to do three things. We have to, number one, check the geometry, make sure all our normals are facing the right way, that there aren't some insane number of faces on some nut and bolt somewhere that we can't see, and just generally check that everything's there and everything's all right. Then we will need to apply the light map UVs. So if you don't know what the light map UVs are, don't worry. I'm going to describe that in detail in a minute, but we will need to do that for every object, and that needs to be done systematically, and so we need to be organized in this way. And then finally, we'll need to export. So like I said in the previous example with SketchUp, it's not a good idea to export the entire scene into one FBX. So we'll need to generate several FBX, and this might get quite confusing. And so we need to be organized. So this, I'm just going to show you a little bit this scene. So make sure I've loaded it. Yes, I have. So that's all fine. The scene from that was handed over to us by Tilt Pixel. So thank you very much, guys, for letting us use this scene. It came as an FBX, and I just loaded that into Max. And as you can see, all my objects were named probably from BIM, and that's quite confusing. There was over 4,000 in this simple model here. So the first thing that I did, my personal way of proceeding, is to separate everything by material. And because it's very visual, I can see it and turn things off. And within that, to create more subcategories in order to manage the file. So here I was able to clearly hide or freeze every other object that I wasn't dealing with while I was checking the geometry and applying my UVs and then exporting. So I'll just show you in the editor a couple of things here that are quite useful to do. So when we've got so by the way, I've used the technology that Epic Enterprise is currently working on to import this model, and so I'd like to say it's working very well. It was all automatic. I selected all my floor plates, exported them, and it generated the UVs for me and imported everything in a very neat folder structure. All the names were correct as per the original file, and everything's working very well and very clean. So this is great news for us. So stay tuned. Look at make sure you check out Chris's demo, and stay tuned with the upcoming news about that. So that's great. That being said, and the other thing about this building here is that you can see that a lot of these panels are effectively very similar. And in fact, there's only 3 different types of panel in the whole facade. So instead of importing all the panels as different elements, which would make my file very big and difficult to manage, I placed all these objects using a script, which we'll give you in a minute, but each one of these panels is referencing one of these 3. So that works very well. And just to show you a little example here, how we can, how beneficial that workflow is. So I'll just select all my guardrails here, and I thought I'd give you a little teapot trick for any respectable 3D demo should have a teapot. So here we go. Boom, I've changed all my guardrails in one simple click into a teapot. So that's not going to make the architects very happy. So let's bring it back to the guardrail. So obviously the scenario here that we could possibly work very early on in the process, put a placeholder, something generic, and then replace it, or apply a design change. And that's a workflow which is very simple and super quick. So let me just check my notes, original names and instances. Yeah, so that's great. I'm just going to shut this file down, and before I carry on, open the other one. Okay, so what other problems are we going to get? This kind of problem where the geometry is just not going to cut it for us. Either this is going to be too low res. I mean, it probably would work, it would probably come in fine, but it doesn't look great for us, whether we want to work with it and so on. So we'll need to probably remodel some things. So I have been asked quite a number of times whether, in terms of modeling, chamfers are okay. And so I've put this little video together of me sort of speed modeling this bit. And here I'm showing what not to do. So I'm just going to pause a little bit here. You saw that I generated this hole in this wall here using a Boolean. And the problem that we get is that the Booleans generated this diagonal here, and here when I apply my chamfer, well, that's not looking great. So fine, say we can fix that by just moving the vertex. Then when we will apply our UV unwrap, then the automatic unwrap is also going to create some problems for us where our chamfer, you see this green line here is delimiting the edge of my map, and then you can see that the chamfer has actually been cut out here in my UV layout. So worry not, I will explain what all this is for, but this is going to create a problem for us, and we're going to lose control. And imagine this happening over an entire facade is going to be somewhat problematic. So I'm just going to fast forward here. You don't want to just watch me model all afternoon, but this is what I mean when you say use polygon modeling and turbo smooth if we're doing some rounded edges or any kind of organic material. This is the proper way to do it. So for those of you who know about this, it's pretty obvious. But here we've got control over all our faces, and when it comes to do the unwrapping, then I've got control over my unwrapping, and I can see all my edges, all my chamfers are in the right place. So yes to chamfers, but it will probably cause some problems in the unwrapping. So that's that. So let me carry on, show you another example of how we dealt with some of the modeling and some of the importing into that lobby scene. If it's loaded, yes, great. So in this scene, I like to just, maybe I can go full screen on that, to show you effectively the difference between the two workflows in terms of modeling. In working with V-Ray, we would have most likely this entire side of the courtyard collapsed as one object. I personally like to use the clone tool. So these would be all cloned and they would all be part of one mesh. We could even possibly have all the mullions into one mesh, and that won't cause us any big problem. Now, in my experience using in this particular scene and in other scenes, actually, it's creating a huge increase in render time to work this way. And I mean exponentially high. So the way that it was resolved was really to separate each one of these, and again use this TS tool script to place the object as instances. So if you see again, I've got 6 different frames here that are repeated throughout the whole scene. And these were all and also I'd like to just show how detailed the modeling was. We really had no fear in creating a very detailed geometry with tiny chamfers that cast the light, and to keep this very high quality of what that we need in architectural visualization. So really we will go far beyond what maybe might be done in a game. So again, just to show the workflow for these instances, so I'll just place myself there for a good view. And we see that this chair, rather than exporting all, selecting all the objects in Max and exporting that and having them in the engine, I've exported one chair and I've placed that using instances into Max and copy and paste into Unreal as an instance. So that works very, very well. I think the engine supports instances very efficiently. Again, for all these plates, all these objects were done using that workflow. So while we're here, there's a thing that you will need to take into account also before you start exporting, is which objects will be static and which objects will be dynamic. So the static objects will generally be the floors, the walls, the ceilings, large objects like this, which will be placed in Max and exported as is. By that I mean you just select and export them. For objects that are movable, and this is a little bit confusing because when I click on this chair, it actually says static here, but we're going to talk about that in another little while. But in terms of the object being movable in 3D Studio Max, we will need to make sure that this object is placed at 0.000 so that the pivot is in the right place. And then these can then be, having imported one object, and this has been copied over. So this is something to bear in mind into our export sort of routine, really. So again, just to show clearly, briefly, and just little hello to my friends at Artifactory, Eric and Dominique, who've worked with me on this file. So thank you very much, guys, for letting us show this here. But that explains the French because it comes from Paris. But again, the layers were carefully thought of so that we could manage each area and deal with it, check through every piece of geometry, and then send it over to the engine. And also, it's good to keep a reasonable number of objects. It's pretty obvious, but manageable number of objects per layer. And when there are a very large number of objects, then we use instances and just export just one object. So here again, this is talking about static and movable. So we've talked about that. So finally, regarding organization, I'd like to point you to this asset naming convention that Unreal have put on their wiki, because this is something that I kind of rebelled against a little bit at the beginning. Thought I've got my own way of naming, but you can see that now I've given in. I prefix the names for my static meshes and the textures and materials and so on. So all this is there. It's not compulsory, of course, but I think it's a good idea to just check it out and to know that it's there. And if you things become a bit confusing, and you can always go back in here and get some good tips for how to manage all these very large number of objects and different geometry and so on. So that's that for the geometry. So I told you this was front loaded. We're still on the 3D model part of it, but we're getting towards the end, the light map UVs. So are we familiar with UVs? Yes. Thanks, Chris. You've done the poll already somewhat. For some people have no idea what they are. So I'll go over quickly and try and give a brief explanation of what they are. Basically, this dates back in the days of scanline render or exporting for games. We could do that in Max. Now this is done in the engine. But the idea here is that we have a texture map here, diffuse, and then we have another texture. And when we combine the two, we multiply the light map by the diffuse, it looks like we're shining a light onto our texture. So this works very well to pre-calculate the light. It's called baking onto the object. We bake it onto the 3D geometry, and the light is done. And then we can move around our model in real time. The light doesn't need to be calculated every time we move the camera, like it does for V-Ray, for example. So this is works very, very well, and this is the way we pre-calculate the lighting for the games as well. So the other thing about this, because this light is effectively now a texture, we need to apply this texture to the object. In the case of the diffuse, most of the time this will be tiled, especially in our case for architectural visualization, we'll tile especially a texture like this. And but we can't do that for the light map, because the light will be different from all angles into the geometry. So we need to unwrap this light, this texture, onto a flat square, and it's the age-old problem of representing a flat image, or so in this case, the map of the world, onto a 3D geometry, which is a sphere, the Earth. So that texture will need to be unwrapped, and this is effectively reminds me of wrapping up a present. Imagine being given the assignment of wrapping up a present that's not a box and where you can't have the paper folding on the sides. Well, this is the problem that is presenting to us. So thankfully we've got tools for that, but it's pretty complicated. A lot of us have never done it before, even if we've been in the industry for a long time. So some people I've heard even consider an art form in itself. So it's pretty complicated, but obviously once you know it, it's not that hard. So quick word about channel 1 and 2. Because we've got our diffuse and our light map, we will need to reserve channel 1 for the diffuse and channel 2 for the light map. So that's for the UVs, for the coordinates of that light texture. So to make things even more complicated, Unreal Engine is going to have channel 0 and 1, just in case you're wondering. So moving on, we have two ways of doing this unwrapping. We've got way number 1, which is automatic, which works really well most of the time. And we've got scripts for that. And we've got the flattened mapping straight into 3ds Max. And that works very well. But we have some problems with that. So there's a manual way. And in fact, I would probably think that in the game and film industry, it's all done manually. Because each one of their object has to withstand a lot of optimization and scrutiny and has to be watertight. But for us, we don't generally need to do it so much. So it's going to be a bit foreign to us. So the links to the scripts I was talking about, we've got, I think Chris may have put them in the chat, and we've got Steamroller, which is going to apply a UV unwrap on your entire scene, and that works very well. The one that I use is this little one by Chris Jennings, Auto Unwrap, and it's very, very simple. It works very well as well. And then this script, TS Tools. So check out the web page on Tom Shannon, where he explains very well how to use it. It's very simple, and it allows you to create this these instances into Max, and this sort of very, very useful copy and paste workflow from Max to Unreal. So this is what happens when we rely too much on the automatic unwrap. Things can get a little bit messy, and so you see that the all I did here is apply unwrap UV and open this and go mapping and the flatten mapping, and it's done a bit of a mess. So this is what we're going to have to deal with, especially on things like furniture and especially on things like cushions, which have a little bit of organic feel to them. So it's going to be a little bit complicated. And the way we want that to happen is like this, just nice, neat, and clean. This is very likely to come through perfectly fine into Unreal. This can be sorted out into Unreal by increasing the resolution, and I'm going to talk about that in a sec, but obviously it's not guaranteed, and it will increase render time. So we're much better off learning a bit of new skill, how to unwrap things properly, and we'll save some time in the long run, as always. So what do I mean by resolution? This texture, which is the light map, is an image like a diffuse texture. So it will have a resolution. And here you can see a little bit of a patchwork of resolutions into the scene. But I've liked to compare it to DPI. So a high resolution, a high DPI will give us a very clean, crisp image, and it's going to take longer to render. It's going to take longer to print, for example. So it's going to potentially cost us more. So this is the same thing when we override our light map resolution and make that higher. We will increase our render time drastically, but we'll have much finer lighting calculation. Here you'll see with this blue one, it's very coarse. And so like with a coarse DPI, it'll print much quicker. But so it's that trade-off. So this is really where our light calculation is, that our very fine soft light calculation will and be very dependent on that light map resolution. So it's time to move on to the next stage, which is lighting. So so Chris, have you? So let me just check. Pause. Oh, maybe not yet, but well, anyway, for those of you who don't know deferred versus forward rendering shading, it's there's nothing really to do. It's something that I didn't know. So sorry, yes, thank you, Chris. Never heard of either of them. Yes, like me, I think most people have never heard of them. I hadn't heard of it, and this is the way Unreal works under the hood. So deferred rendering means that it's a little bit like we have several renderers which are acting on top of each other like layers. In fact, it's a little bit like when we render all the different passes and composite them back into Photoshop. And so this is an illustration of all these renderers, and then they're all stacked on top of each other, and that has some consequence into the way we work and something that we're not necessarily used to. So as the deferred renderer as opposed to the forward renderer, which is the way V-Ray works, where really it fires one ray from the camera, and when that ray hits a piece of geometry, it asks what's going on and returns the appropriate color for that pixel. Now, before you quote me on this, deferred renderer is the way Unreal Engine works, but also since version 4.14, I think, you can also enable forward rendering. So if you look that up, and I recommend you do, forward rendering is specialized for mobile and VR. So if you're going to do VR, we will probably have gain from switching to forward rendering in Unreal, but we'll talk about that in later webinars. So deferred versus forward. So knowing that, I'm just going to take you through the general workflow of lighting in Unreal and see how this deferred affects us. So here we've got our skylight, which is, if we've used V-Ray before, it would be the dome light or the environment that we'll use, and HDR. So here the HDR will be plugged into the skylight, or we can use the default sky that comes in when we open a scene, or we can even use blueprints like the BP sky in Unreal. So the another thing that will affect our image is the environment color. So here, in fact, we see, well, the environment color is going to be added to the skylight. So in V-Ray, for example, if we've got a background environment color and we add a dome light, the dome light will cancel out, cancel out the environment color. In Unreal, the environment color is going to act on top of the skylight. They will both be active. So we can see those two renderers acting on top of each other. Another thing that we've got in Unreal is the atmospheric fog. So that will contribute to the color of the sky, to the color that the skylight will use to throw light onto our geometry. In V-Ray, it's quite customary to add any fog in post-production, and so that means that the fog will not participate into the lighting of our scene, into the color or things like that. So that's something that's changed that we need to take into consideration. The sunlight will come from the direct light, so there's no in V-Ray, we have the V-Ray sun. We don't have a specific sun in lighting. It's the direct light. And what's the particularity of the direct light is that all the rays come in parallel, like the sun being so far away will throw a direct light onto us. So let me just quit Skype so that it doesn't pop up on us all the time. Lighting, so the light mass, that's the GI solution from Unreal, and the GI, for those of you who don't know, is the calculates the bounce light. So in this diagram, it calculates the light bouncing off the floor, but obviously if we've got geometry, it will calculate the light bouncing from one surface to the other. The reflection probes is something that we'll need to systematically put into our scenes. So again, here in V-Ray, we never need to think about this because the reflection comes from the environment. Here, again, this is something which enables us to remain on par with our real-time expectations. The reflection probes will pick up a reflection from wherever the probe is located and enable the that reflected image to be used for the reflection pass on the material which are nearby. So it works very well because it pre-calculates all the reflections, is very fast, and it works well. The only problem is that it's not very accurate. So it's very quick, but it's not accurate. If we want more accurate reflections, and in architecture reflections are very important, we will use either screen space reflections, which also work very well, but the later edition, I think, again from 4.12, the planar reflections is what we'll use. So I'll show you that in a minute. So that's great. All this is great theory, but how do we get a clean render with soft shadows, a little bit like this? So I'll just jump into this scene, and I'm just going to check that the other one's loaded before. Yeah, so I didn't load it. So I'll load it now before I carry on too much. And so here in this scene, what settings did I use? First of all, I used these light mass portals. So they're very simple. You just, from your modes panel, you just check the portals and drag them into the scene and place them where your openings are. It greatly increases the quality that I've seen into the light mass calculations. And I think it probably makes things a bit quicker as well, giving the light mass indication of where to concentrate its rays. The skylight, you will see that in this particular scene, I've used a flat white, gray cube map for the skylight, and to give this very white light. And the intensity here is set to 10. So it's something that's quite usual to have a high skylight for an interior, but you'll notice as well that I've actually boosted up the environment intensity in this instance to throw large amounts of lights into this scene here. So we'll go over that into the next webinar about lighting in a little bit more detail. And but just quickly here, I've got the static. For those of you who are familiar with these light mass settings, the static lighting level scale I've set to 0.75 and the lighting smoothness to 0.75, and that I do that consistently now. I always use these settings, and they work very well for me. And the indirect lighting quality here I've set on 8, which is really high. I've not had a need to work on sort of values like 10 or 20 anymore, and I usually work between 1 and 4, which are the accepted values from the slider here in Unreal. So that works well for me. And so here I just I'm going to jump in the interface to show you a little bit about the light map settings here. So yeah, it's open. Great. And so, by the way, I'm in 4.16 with this fantastic volumetric fog here. So I'll show you that more of that in a minute. But just to say that I systematically now, when I work with light map resolutions, I will systematically spend quite a bit of time going to my light map density mode here. So we can work with that, or I used the keyboard shortcut. So between Alt 4 and Alt 0 here, and I will do quite a lot of testing and to make sure I've got the right light map density. So like I was explaining before, the fineness of this grid, and that reminds me really of the Matrix here, where we've got this grid overlaid onto the entire scene, and it's set by object. So the only thing is that if we set the light map resolution for all the objects in the scene, here we've got a value of 840. So I'm not actually sure whether these need to be power of 2 or not. It seems to work like this. So I tend to look at the color and the visually that does, and the size of the little dots here. But if you see that this orange looking floor is set on 840, and I grab this sort of handrail here, this is set on 264, which is a quarter nearly of the resolution of the floor, yet they're almost the same size. So if we set, say, a resolution of 512 on everything, it might seem high or low, but for some objects it will be high and for some objects it will be low. So we really need to go over everything and to check that it's the right size. So for example here, I missed out this object altogether because it was hidden, but here we've got a very low, in fact, it's not been changed, but it's 64, and that probably won't give us a very good result. So it needs to be quite fine, and it needs to be checked. So while I'm here, I will show you, so I'll go back to my lighting mode, and while I'm here, I'm going to talk a little bit about about static and movable again. So static, while in Unreal, and this is valid for the lights and the objects, is the static and stationary objects will be calculated when I calculate my light here, my build my lighting. And so the skylight is set to stationary, and it's incorporated into the lighting calculation, and once that's done, it's baked onto the geometry, and I can now enjoy my pre-calculated light. If I want to move the light, like for example in the case of this sun, then I've set on to movable, and in this case, so if I turn the light on and off, you'll see that if you look at the ceiling there, it doesn't affect the light. It's not part of the pre-baked lighting calculation. So that's a trade-off, but you will see that I can move it, and I can, for example, create, I can interactively move it into a presentation, or I can create a nice movie of the light moving about. So, and I'm sure that now with this new volumetric fog effect, we're going to have plenty of moving sunlight through windows, because doesn't it look great? So yeah, if you want to make movies, or if you want to animate the light in any way, or for it to cast dynamic shadows into the scene, it's probably going to be best to set it onto movable. On the other hand, if you want to make your light interactive, so that your customer or client is able to turn the lights on and off like this, then you should probably actually set it to movable as well, so that the lighting has not been pre-calculated. Like you see here, it wasn't, so it was actually set on stationary when I calculated the light. And even though the light is turned off, there's still the GI being shown on here. So that's incorrect, and will look a bit strange. So that's for static and movable. It's the same thing about geometry. If a geometry is set on static, you will see nice contact shadows on the floor, and if it's set on movable, it won't be calculated into the light mass. Great. So keeping track of time, I'm going to exit this one and load up my next one and carry on in the presentation and to materials. So materials, a lot of new things in there. First of all, the new node-based material, so that we don't even have the simple version that like we had in 3ds Max. No, this is it. And it looks pretty daunting because we have all these nodes here that are very complex maths and a bit scary for some of us artistically minded people, maybe. So I just want to say, don't worry about all this. Really, in order to get cracking, to get started with this, you really just need 4 or 5 nodes to build pretty complex stuff and to make materials that look great. So in this instance, I've built a very simple material, and it's just a set of textures, values, multiply, and that's it, really. So there's no need to get complicated. Start simple and you can get some great results. So this is the workflow that I try to adopt. I like to try and always go back to things I know. So here, this is our old material editor from Max, and we just got our, for example, here for the diffuse, we've got a texture map and a value and intensity of that map, for example. So I try to replicate that where we've got a texture, a placeholder for a texture, and then a value. And one thing that Unreal really allows us to do, and if you've seen the first webinar, you'll have seen me demo that for the instance materials. I've created this simple material here called Simple Mat, and I've created an instance of that material, which then allows me to tweak all these parameters in real time. So I can really move these around and check and change all my colors and values right there in the interface. So that's really, really useful. So again, you can see that I've set my diffuse and my intensity, and here I've got my diffuse. I've replaced the texture and I've got the intensity here. So what does the diffuse do in this case? It would lighten the image or darken it. It's not exactly the same as this, which will give us effectively expose it on top of the color. This works a little bit differently, but I try to have, so here I was just being lazy. I didn't put a texture, and what these values mean are effectively a value of gray. It's the RGB. The lazy version of the RGB was just one number that is plugged in for the 3 color values. So this is not just a number, it's actually a color, well, a gray. And you'll see that it's also from 0 to 1. It's decimal values. And so that's a little bit comparing here to the old color selector from Max, where from 3ds Max, where colors go to from 0 to 256, which doesn't make sense because that's sort of 8-bit. So here, this is proper high dynamic range values, and so effectively it's a problem we don't have anymore, which is great. Less problems, more new problems. But yeah, so here's another one. PBR workflow, the physically based materials is something new. It's something that is going to take a little bit away our power to just grab any texture off the internet, do an image search, and then use that. It's the proper way to use this workflow is to have, for example, the albedo is a texture which is totally void of lighting information. So it's completely just color. So it's something that's quite difficult to generate. This is the screenshot from Megascans. So we can acquire these textures. We can buy them off websites like this, or there's plenty of others. But it means that it's a little bit more difficult for us to just do it in-house. Another great way of generating these different textures is using Substance Designer here, which is being used throughout the gaming and film industry, and where a lot more people are seeing the benefits of it. So we can create these nodes straight away, base color, roughness, and these will be properly plugged into the engine. So we'll talk about that in the material webinar at length. So practically, the PBR workflow, this is how I use it. The albedo is the color information only, so we've talked about that already. Metallic is, as I understand it, is effectively an on-off switch. Either the material behaves in a metallic way or not. And obviously, that's something which you can be completely free with. If you want to add, if you want to put in a value in there, by all means, experiment. This is the rules are here to be broken. But you will notice that there is no reflection in here. So metallic is not intended to be the switch for reflection. It really is a node which will make the material behave in a metallic way. The reflection will be greatly dependent on specular, and it's good to know that if you, for example, work with a very simple color flat white material, you will have a default of 0.5 specular, so halfway. So there will always be some reflection in your material. Regarding specular values, I set mine around 0.2, so high values don't seem to make much difference, and very small changes around these values have a big difference in the look of the material. Normal, not much. We'll talk more about how to generate these in the material webinar, but here I'd just like to say, in architectural visualization, we want to keep the normals very subtle. It's all about very small details, and it's very easy to make these far too strong, and they will damage our image rather than the opposite. So the roughness here is bold and gold because, well, this PBR workflow, although sounds a little bit complicated, I think it's made our life much easier. It's much simpler because for me, this is where most of the work is going to happen. A lot of tweaking, a lot of time spent working on the roughness and a little bit on specular to break up the specular highlights. But the roughness is like the glossy reflection switch in V-Ray. So obviously, we know that in V-Ray, glossy reflections are very expensive in render time, and that's the cost. But in Unreal, we have a very glossy or a very rough material is not going to cost us more time to render, so we can really play with this and have very so rough materials like concrete and brick and so on, or very non-rough with a very low roughness value, and that's going to be like a mirror. As roughness of 0 will be like a mirror. So it's a great luxury to be able to work on this glossy reflection on all our materials, and so effectively a material which is very rough will still be reflective. Reflections, while we're talking about it, we have these reflection probes, and we've got two types. The sphere is the one that I would probably assume is the most commonly used in games, especially for exterior, because it will capture the environment as a sphere and throw that reflection onto our object. Now, because we work in architecture, we will tend to have more orthogonal type spaces, and for those, the box reflection capture will work better. It will match our spaces a bit more, and it will So it's a little bit trickier to use than the sphere reflection because the boxes will overlap and we'll need to manage this overlap. So it's just a little bit more fiddly and takes a bit of time to get used to. But the box reflections are really the best way to handle these spaces. For both the sphere and the box, we will tend to need to increase the resolution. So if you go to edit and you go to edit, project settings, and then rendering, and then you come down to reflections down here, and you can increase the resolution of your capture of your probes here. So it's something that you might want to do after you've placed them in the right place because it slows it down. But it's a good idea to, in architecture, again, reflections are very important. We want them nice and crisp, and so blurry. The low resolution gives reflections that are a little bit too blurry, I think. So moving on, the planar reflections is what I've used in this project for the floor. And you can see that here we've got very accurate reflections. These columns here are properly in the right place on the floor. And with a little experimentation, you will see that the reflections given from the probes don't do that. So here it solves our problems, and it works very, very well. It shouldn't be overused because they takes quite a lot of resources. So again, trying to stick to our real-time aim here. So quickly about this floor material while we're there, again, I used the planar reflections. I used the instance material to play around with these values and spent quite a great deal of time to not only go back and forth between my original material, build all the nodes that I needed on there. Under the hood, though, it doesn't look too complicated. And like I said, there isn't these are all values, and there's a multiply node and a linear interpolation node. So this linear interpolation does the same thing that the mix map does in Max. So we'll just have one texture overlaid on top of another one, which have different tiling values, and they will be overlaid according to a black and white image, a third black and white image. And so that's very simple, and it works very well. Again, I've got very simple values for the metallic and specular, and a little bit more work on the roughness. So here I've got a linear interpolation as well that's overlaid onto a black image. And the normal, nothing fancy, just a little bit of control here to multiply the color to tone it down most of the time, tone the normals down. And so quick couple of tips, texture sizes. Low res textures really won't do anymore because in real time we can walk around and we can come and look at objects very, very close up, and a low res texture is really going to not work in our favor. So work at high resolution, and Unreal can take up to 8K textures apparently. I haven't tried it, but I've tried 4K and it's behaves without a problem. So again, little nod to Substance Designer, because we can generate these high-res textures here, just going from I just had to move up these sliders and I went from 256 to 4K, with no effort or no cost. So it's a good idea. I think we'll see that into more detail, but it would be quite difficult to change a texture from, say, 1024 to 4K in Photoshop. It could even be impossible. So this is you can understand why other industries have adopted the software. So another tip, again, just from in our material editor or in the UV map modifier, we've got this tiling values here, and it took me quite a while to figure it out, although it's a very simple solution. But in order to have a tiling into Unreal, we just add a multiplier to this text chord node and just plug in a number. If you want to play around, make this a parameter, and you can play around with the tiling in real time into your viewport. But yeah, I thought I'd let people know because I was doing something really complicated to do this when I started. So this is really simple. Okay, so very quickly to finalize, because I'm sure Chris is dying to show you the tech demo, the post-process volume. So oh no, I didn't. I did not forget to load it. So great. I'll just show you super quick what a couple of things that it does. If you're not familiar with it already, we can do all this color correction and much more inside of Unreal Engine. So actually, I'll just jump straight in, and I've got my post-process volume here. And so what I've done here is use this color grading LUT, and you can see that when I turn it on and off, it really has quite a drastic effect onto the look of the scene. So look it up into the documentation. I really recommend using it. It's absolutely straightforward. It's very easy to use, and it makes a massive difference. So, and another thing which is a little bit, so we'll talk about the tone mapper and the lighting, so stay tuned for that. And a thing that's a little bit confusing now is that we've got this depth of field here in the post-process. So that is quite difficult to use, and we've got a great new way of doing that with our new Cine cameras. So, well, new, probably not so new anymore, but that's, if you want to do depth of field here, this is how I've worked it out. We've got this lens setting, so I sort of didn't realize that you can, for quite a long time, I was sort of looking for ways to use the depth of field in here, and I missed that altogether. So we've got the minimum f-stop here, and I bring that down to a ridiculously low, unrealistic value of 0.2. So there's no, I don't think there's probably a lens in the world that goes that low, but it enables me to go really way down, and you can see that my blurriness in the scene really increases. So if I'll just move the camera a little bit, and I'll just zoom in to make it a little bit more obvious, you can see that my foreground here is very blurry and the background is very blurry, and I've got this draw debug focus plane, and this plane here is moving in the scene and gives me my area of focus. So if I want to focus on these chairs, I just move my plane and then untick that, and so my value here is probably way too high. So just tone it down a little bit, and so we've got my chairs in focus and the area around the chairs, and then my foreground is nicely out of focus, and so is the background. So that's how to do depth of field. While I'm here, we had a little bit of discussion in the previous webinars about this. This scene has no light mass calculation. It's entirely with dynamic lighting, dynamic skylight, and dynamic sunlight. So there is no render time, absolutely no render time. It's all thrown in. And so that's for exterior lighting. This is my recommended setting, but we'll talk about that again in the future. Right, so quickly, nearly finished. Going back to my PowerPoint here, very quickly, interaction and output. So I really realize I've put an enormous subject here into just a few minutes at the end, but navigation, I use a blank template and import whatever template I want afterwards, but do work with a VR template if we are doing VR. That works very well. And then the first person shooter, if you want to walk around, there is an ArcViz solution here that's I haven't worked out in great detail, but the first person shooter is what a lot of people use. And then the for the output, just very quickly, if we're providing services using Unreal Engine, whether it's in-house or freelance, I think there is definitely a market already, people preparing scenes to be viewed in the editor. Just pressing the F11 key and the G key makes us in game effectively, so we can present that straight away. And I think there's already a market for that. In Editor VR, if you haven't used the latest version 4.16 VR editor and you have an Oculus or a Vive, check it out. Go in it and work with it. I think it's really worth being part of the development of this tool, because it's very likely that we're going to be working in it in the near future. So I won't go into much detail about the rest, but as you can see, it's ranging more difficulty. When we work in VR, there's quite a lot of new things to take into account. And when we work with mobile, we've got the added constraints of low power for mobile. So it's more difficult to send things out this way. And then just quickly for the high-res stills, I just recommend you look up this NVIDIA Ancel plugin that comes with Unreal. So it's pretty straightforward to activate, and you can output stills up to 60,000 pixels across. So that's pretty massive in a couple of minutes. And you can do all sorts of capture 360 and so on. So that's a really fantastic tool for us. So finally, if you want to know more, check out my YouTube channel, subscribe on there to get any new videos that I'm going to post on there very soon. And if you want to check out my website, I've got a couple of courses there and a lot more coming in the near future. So check on there. You can register for my newsletter, and I'll keep you up to date with any developments. So that's that from me, Chris. If you're still here.
I am Fabrice.
Hand over.
Well done. Marathon session there. That was great.
Yes.
So go ahead and unshare your desktop if you can, Fabrice.
All right.
I think you're still shared. There you go. Great. And hopefully you'll join back in. So thanks, Fabrice. We're almost done. I have a quick little tech preview I want to share with you guys. Some things that we've been working on at Epic around these workflows. It's a pre-recorded video. It's only about 5 minutes long. But go ahead and check it out, and I'd love to hear what you think about it. And we'll be doing QA for all of you that have been posting in the chat room. We'll be doing QA immediately after the video. So hang out, and I'd love to hear what you think. So I'm going to go ahead and start the video, and we'll be back in a few minutes. Okay, so we're going to take a look at a technology preview of some things that we're working on at Epic. The goal here is that we want to make the adoption of the engine super simple for people who are doing design and architectural visualization. And we want to address some of those workflow issues that we're currently seeing with people who are using the engine. The biggest hurdle at the moment is getting data in a fast and efficient way. While there are certainly lots of different things to be considered when you're moving data into the engine, if we can shave off, a certain percentage of that work and make it a lot easier to do it, we believe that will really benefit our customers who are using the engine. So we've created some technology that really automates and accelerates that process. So I've got a V-Ray scene here, and it's V-Ray very specifically. We recognize that a lot of people are using V-Ray for their work in 3ds Max, and we think it's important to try to replicate that workflow as closely as possible in the engine. So I've got a V-Ray scene here that has V-Ray materials. You can see I just have some real simple V-Ray materials set up at the moment. I also have some V-Ray lights. So if I choose my light filter and I select the lights, you can see I have some V-Ray IES lights in here. I also have a standard V-Ray area light there. You notice that some of these lights are just white lights and some of them are colored. So pretty simple setup. I also have some CAD geometry in here. If I click this and zoom in on it, you can see I have a CAD model of a radio that came over. Thanks to Adrian Wise for sharing that with us. And finally, you'll also notice that I do have some cameras in the scene. I have a standard camera here, and I also have a physical camera here. So two different types of cameras in the scene. Let's go ahead and move these things over to the Unreal Engine so you can kind of get an idea of some of the things that we're working on. So I'm going to go ahead and choose File, Export, and I'm just going to overwrite one of the files that I used previously. So we'll just say yes to that. So I've blurred out some of the things here, but you can see that basically we have some choices about some of the things that we want to assist with in terms of moving data from Max over to the Unreal Engine. So we have a couple of different settings there, but again, there's no guarantee that any of these things may actually end up in whatever piece of technology we should make available. So I'll just go ahead and say export to there, and we'll let this thing export automatically. We'll say OK there, and we're done. Now let's hop over to the Unreal Engine. So now you can see I have an empty level here in the engine. I'll just go ahead and do File, Import, and we'll go get that preview file. And again, just blurring out a couple of things, but you can see we're going to have more options here. And we'll go ahead and import everything. And this does take a few minutes, so I won't cut the camera away, but I will actually accelerate this so that we're not sitting here waiting. Okay, so our content has been brought into the scene, and you can see there's really good parity with what we're seeing in the Unreal Engine versus the 3ds Max viewport. You may also notice that all of the materials are hooked up. We recognize that that's a big challenge sometimes, so we want to automate that workflow. Again, it's not necessarily a one-click solution, but it's as few clicks as possible. We're trying to make it easy and simple and quick to get your content into the engine. So you can see that our lights are here. Those have been brought over. You'll notice those are V-Ray lights over in the scene. Our area light has come over. Also, the individual cameras that we had in 3ds Max, both the standard camera and the physical camera come over, and each one of these cameras is different in Unreal. This is the standard camera in Unreal, and this is the cinematic film camera that's in Unreal. The other thing that we should take note of is in our world outliner, all of our objects have come over. We've respected Max layers. If I choose the Layers tab, you can see those are the same layers that we had in 3ds Max. But also, all of the objects are grouped by type in the world outliner. So cameras are in one folder, geometries are in another, lighting is in another. This is going to make scene organization super simple. We recognize that scene organization is a really important part of the workflows into the engine when you're coming from places like 3ds Max or other CAD packages. We know that that is going to be really important to you. You can also see that everything has been organized in our content browser. File folders have been created. Everything is in its right spot. You'll notice that each individual object has been brought in as a separate FBX file. So you can work with them in the engine or in 3ds Max. You're not stuck working with one single FBX. So again, just a little technology preview. Hopefully we'll have some more to share on this as the year goes on. So we'd love to hear what you think about this. Please feel free to leave some comments in the chat, and hopefully you'll be able to see more of what we're doing as the year rolls on. So that's a little preview of some tech that we're working on. Hopefully we'll be able to make some announcements on what exactly will be available later this year. So again, just wanted to show you some of the things we're thinking about. When people are working with CAD models, whether it's AEC or manufacturing or all types of design visualization, you're really frequently working with a number of models, several orders of magnitude greater than what a typical game developer would work with. So moving large amounts of 3D data into and out of the engine is really important, and we want to streamline that as much as possible. So hopefully you had some interesting thoughts about that. I think it's probably time to jump over to Q&A. So I'm going to move the chat window over here so I can get a better look at the questions. So let's jump in, Fabrice. Did you see any, have a chance to look at the questions? There were a couple of interesting ones in there.
Yeah,
Go ahead.
so well, I'll just pick a few there. Regarding import from Blender to Unreal, I'm unfortunately not familiar with Blender, so I'm sure there will be plenty of answers on the web about that. But hopefully, I'll be able to answer that in a few months when I'll have had a look at it myself. But next one is about the light map setting on the curtains in the Farnworth house from SketchUp. Well, very strangely, these light map settings, when I shut the file down and open it again, they were gone. I did also build the lighting. So this is sometimes things happen by magic. And I'm not quite sure what it was. It might be an internal setting that had been turned up, and that one was a lucky one. So that's the next question here is: should I stop using Cinema 4D? Why? Because if you're familiar with Cinema 4D, I don't really think there's necessarily a need to use 3ds Max unless you want to use the technology that's provided by Enterprise here that Chris has just showed you, because that's going to be specifically for 3ds Max. But like I said at the beginning, it's more about having a 3D app which is going to manage the geometry for visuals rather than construction issuing.
Yeah, and let me just add on to that, Free. So, yeah, that technology preview that I showed, we're starting in 3ds Max because honestly, that's where the majority of the people are that are moving data into the engine are coming from. If Cinema 4D is your tool, you should definitely stick with whatever enables you as an artist to get the best imagery out. There's no technical reason to switch. It's really more of a workflow reason. And that's also not to say that at some point in the future we wouldn't have some similar workflows for Cinema 4D. I know that our current area of interest lies in 3ds Max, Rhino, and Maya. So, and those are just, type of exporter type solutions. We have a lot of other things coming down the pipe for, much larger data sets, like for things coming from CAD packages like SolidWorks and stuff like that. So what I've shown here is really just a small part of the bigger picture of what we're working on.
There's an interesting question from Mark here talking about Unreal units. So the units in Unreal are centimeters, and you better just set up your scene in centimeters. If you're working in 3D Studio Max, make sure it's the actual working units, because well, I've tried to work in meters and use the FBX exporter to scale things to centimeters, but I had no success whatsoever. And so my only recommendation was just to make your life simple and set up a scene in centimeters. That's the unit that Unreal works on internally anyway. So it's good to bear in mind when we're working with any other settings inside of Unreal, it's going to refer to centimeters.
There's a couple questions on light maps, how to prevent dark edges. Irvin was asking that. That sounds UV. It could be a UV wrapping issue. A lot of times, if you do an automatic UV unwrap, when you have anything that's automatic in any program, you're essentially giving control away to the software, and it's making a decision based on what it thinks is best. If you have dark edges on a specific object, you might want to revisit the UVs and just relay out those UVs for that object specifically. Keep it away from the edges, give it a little bit of spacing in there. Maybe be a little bit more deliberate on the UV clustering and how that's happening. I think if you have a problem area like that, besides light map resolution, you definitely want to make sure that you have the best UVs for that.
Yeah, I would just add, maybe if you use 3D Studio Max, increase the padding between in for the automatic unwrap. But again, something that may work but is going to be costly is to increase the. I don't know if you're referring to dark lines on multiple objects, in which case you might want to find a something you can apply to the objects all at once. So maybe increasing the resolution of your light map will work for that. Or if it's just one object, like Chris says, just go and revisit the UVs. But if it's many objects, you can go back into Max and increase the padding, and hopefully that will sort it out.
Fernando was asking which is the best workflow from Revit to UE4. Right now from Revit, I think you can go straight FBX into the engine, but honestly, most people stop in 3ds Max to either do scene optimization, scene organization, do layers, or not groups, but hierarchies, or just basic scene organization. So most people are stopping in there. One of the things that we're working on with this tool is the ability to, get a direct line into the engine from various applications. So, I could see a day at some point where a direct line from Revit to the Unreal Engine is a lot better than the way it is today.
Yeah, that's everybody's dream at the moment.
Right.
But we'll still see. Justin is talking about optimizing for mobile hardware. So still there it will need to be managed in some way or another. And until we can maybe do that straight from Unreal, like polygon decimation and retopologizing maybe, or at least optimizing our UV layouts, that has to be done into a 3D app, unless Unreal one day gives us the option to do that inside. But for mobile hardware, especially for an iPad, you're really going to have to do an enormous amount of optimization. And but I guess it's forward rendering, and it's, if you look at the demo scenes that Unreal have provided for mobile, you will see that it's an enormous amount of optimization for things to look decent. We're not quite there yet for a proper real-time experience on the mobile, I think.
Speaking about performance-related issues, Zarborg was asking, and I wanted to make sure that we talked about this. His question is there a triangle limit that we shouldn't go past in order for the engine to be able to keep up in real time? I keep hearing things that high poly count assets are bad. So it's all about perspective. If you're a game developer, you're making, games that are going to be distributed on various platforms. Everything that a game developer creates is a one-off. Everything is tweaked to the nth degree, as few polygons as possible. It's all about efficiency, because they're shooting for 90 frames per second if it's in VR, 60 frames a second. Other places, really, they want the highest frame rate possible. And in enterprise, customers frequently are doing the opposite. It's not that they don't want good performance, but they're coming from a world where they're rendering in V-Ray or Arnold or Corona, where they're used to 10 minutes a frame or an hour a frame or a weekend for 30 seconds of animation, that sort of thing. So you don't always need to have 90 frames a second, right? So for example, we brought an engine, engine is the wrong word. We brought a motorcycle motor from SolidWorks into the Unreal Engine. It's 1,500 explicit objects over 4 million polygons. And we're running it at between 30 and 50 frames per second. We were able to navigate it in real time, all the way down to the level of the bolt. And we didn't optimize any of that geometry. Now, it's totally not acceptable for VR. It's probably not acceptable for a distributable executable, depending on the use. But keep in mind that a lot of people are using the engine for still image rendering. And so if you're getting 10 frames a second, that's huge. That's great. I mean, compared to 10 minutes a frame for one frame, you're getting 10 frames in 1 second, all at a photoreal or near photoreal quality. So you can definitely, you want to be smart, all right? Just because the engine can take a lot of polygons doesn't mean that you should be lazy with your geometry, but you can take a lot of polygons and put it in the engine. We've had a whole motorcycle in the engine that's over 7 million polygons. I know of customers that are doing 20 million polygons. And of course, the frame rate is completely tanked compared to a video game. But if your perspective on rendering is hours, minutes and hours and days, 10 frames a second is going to be like, Christmas. So hopefully that answered your question. So yes, be smart about your polygons, but don't be afraid to throw stuff into the engine.
And if I can just add to that, Chris, that the other technology that we're not very much used to using in visualization is LOD, which is something that's very absolutely widespread in games, where an object that will be far away will be only showing the low res version of it, and when it comes close it will load the high res. So for example, in the last scene that I showed of the glass house with the grass around, this is every single strand of grass is showing. So I don't know how many millions of polygons is that, but the way I got it to display in real time is that I really worked the LODs in there. So anything that's in the distance is showing one polygon, and when it comes closer, there's a lot more animation. I think the performance we can gain from adding LODs to our objects is enormous. Again, it's something that would just cost a bit of time and a bit of skill to gain, but we will be able to load an enormous amount of geometry into our scenes with the LOD technology, combined with the power of the engine and high performance graphics cards and things like that.
We're almost out of time. We have time for just a couple more. I'm going to do a quick fire one here on a couple that I see that have just come in. David, about recommendations for converting photographs. I'm assuming that's point cloud data or some other type of photogrammetry tool. Check out a tool called Instant Meshes. Google that. It was a SIGGRAPH white paper a couple years ago. There's now open source software that will take any point cloud and convert it into a 3D piece of geometry. It's called Instant Meshes. Someone was asking about the pricing for the Unreal Engine for ArchViz. The engine is free. Go ahead and download the engine and get cracking at it. The way Epic makes money is if you make a video game and you sell it, we get a royalty of that. If you're not making video games and you're just doing graphics and visuals, you can use it all you want. But at some point, we're discovering that many people need some special support or some type of, maybe they want to start developing more complicated things than they're used to. And so we have the ability to work with people on a price per seat model that gets them higher levels of support and gets them deeper access into the development teams at Epic. So you can start off for free and you can continue to work for free, but obviously as we move forward, as you move forward in your skill sets and your pipeline grows, we have opportunities to engage in business with you there. Anything? I mean, there's tons of questions, but we're almost out of time. Fabrice, any last ones that stick out at you?
Well, I thought I just mentioned this one by Oliver talking about mimicking V-Ray object ID render pass. So that's he talks about the custom depth stencil value. So this is to be able to separate out the objects, I assume, to take into another editing package. So that's I haven't done that because I've really used this final pixel idea to just keep everything in Unreal. But it's very interesting. I would say that I'm not sure how well that's going to work for animations because of anti-aliasing. I think it's probably not going to be consistent enough to be able to render different passes and to have things as precise as object ID. But I might be wrong. I unfortunately don't have an answer for that, but I'm quite curious.
Right.
If anybody else does.
Right. So, well, my friends, thanks so much for doing this. I know we still had a lot of questions we weren't able to get to, but we are just plumb out of time. I know it's getting late for Fabrice there over in the UK. I want to say thanks to a couple, right? I want to say thanks to a couple of people. Thanks to Tilt Pixel for providing some content for us and Adrian Weiss for also providing some 3D models. And of course, the furniture models in my tech preview were from TurboSquid. So thanks to that. Thanks to everyone in the room for spending the last 90 minutes with us. I know this was a bit of a marathon webinar, but we wanted to make sure it was jam-packed with lots of information, and hopefully you got a lot of value out of it. So keep an eye out for a survey after that. And keep an eye out for our next 3 webinars. Lighting and materials and VR production, those are all coming down the pipe. And hopefully we'll have some things to announce with our technology here in the near future. So thanks, Fabrice.
Great.
I appreciate your time. Thanks, everyone. Have a great day.
Chris. I'll just finish off. I see people here asking, where do we go from here? So I'll just put in, there's some classes on my website. So
Go for it.
if anybody's interested, I'll just put that straight into the chat and you guys can click on that. Any questions, give me a shout. There you go. But thank you very much, everybody. It's been a pleasure talking with you.
All right. See y'all later. Thanks, everyone.
All right. Bye.
Bye.